Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 42 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we see an electrical circuit. Voltage across a resistor is directly proportional. So there's your clue right there when you see that term directly proportional, or sometimes they might say varies directly. Either way, when we are seeing those phrases, we know that we're going to use this equation right here. Direct variation, y equals kx. It's kind of similar to your slope-intercept form. That k is the slope, just like m is the slope. You notice the difference here is that there is no plus b. Doesn't exist. So there's just a constant right here. That x is our slope. We multiply that by the independent variable to get our dependent variable. So if we were to graph this, whatever it is, it's going to go through the origin. That's one of the things about proportional relationships. So if a current of 12 amps produces 120 volts across a resistor, how many volts would a current of 1.5 amps? All right, so we need to identify what is going to be our independent variable. So remember, our x is our independent variable. That's how things start. You multiply that by whatever that constant is, that k, and you get your y, your dependent variable. Sometimes they label them. In this problem, they don't. So you notice how it says here, a current of 12 amps produces. So it starts with the amps. You always start with your independent variable. So our independent variable is going to be the 12 amps. And it produces, something happens to it, and it produces 480 volts across resistor. The resistor is kind of acting as our constant. All right, so we have our y and our x. Now, how do we find that constant? Well, you see we've got this right here. Another formula that was given to us in the 7th grade, maybe even the 8th grade. We don't have it anymore, but it's easy to derive, is how to find the constant of proportionality. Well, if you isolate that k, right, you just divide both sides by x. So k equals y over x. That's the constant of proportionality. But it's easy to derive that just by dividing both sides by x. All right, so let's divide our k equals, I'm going to get my 480 over 12. All right, so 48 goes into 12 4 times, extra 0, so there we go. K equals 40. All right, so now I've got my k equals 40. I just need to now plug it back into how many volts would a current of 1.5 amps? We need to remember where this 1.5 amps went, and this was on the x, the independent. Okay, so we're looking for y, our volts. That is our x. So y equals kx. So y equals, let's plug in what we have, 40 times 1.5. All right, so we can get out our calculator. Well, we can also just do it by hand here. 41.5, 0, that's 20, and that's 40. So it looks like 600, but remember we got one digit behind the decimal, so it's just 60. So y equals 60. Now this is a problem on the test that does not have A, B, C, or D, or F, G, H, or J. It is, remember, one of those free response, griddable response. So in Algebra 1, it gets a little bit weird. You've got 7 different boxes you can put them in, and they all have the options. 1, 2, 3, 4, 5, 6, 7, there we go. They all have the options of everything. That's a floating decimal. So you can put it anywhere, so I would just put it over here at the end, bubble in the 6 and the 0, and you're good.